What up, calculus students? Lesson 3, Unit 4 is on inverse derivatives. We just talked about e to the x, log x. We noticed their derivatives related kind of to each other, but then we just went into inverses in general. An inverse, if you are an inverse, what are your slope relationships? And what it came down to is that, like, if your function has this point a, b, and let's say your derivative at this x coordinate a is c, the inverse function, which can be either written as f inverse or typically we write it as g, so long as it's provided like you have this statement like f of g of x equals x, or that or that g equals f inverse. It needs to be stated like what g is. We use g a lot in this class, so like don't think that all the g's that we used before, it depends. It just all depends on the situation. Well, g, to be an inverse, you got to have the flip flop point. Like F's going to take A, go to B. G's got to take B and go back to A, so that you get this whole G of B equals A, F of A equals B, so that the whole F of G of X is equals X situation. So points have to get flip flopped. And then we kind of noticed this, and our intuitions were correct. The slopes are ending up being flip flopped. It's like this is a dB over dA, like a change in my B's over the change in my A's. Well, this is like then going to be dA over dB, which is 1 over dB over dA. And that might be confusing. Uh, Mr. No. Oh, she put them up just for fun. Okay, that's cool. I'm cool with that. Yeah, yeah. All right, sounds good. Okay. All right, where were we? So that's it. This is like a dB over A. This is dA over dB. dA over dB is like 1 over dB over dA. That might be confusing. So I'm just going to keep it like this. A, B, C, B, A, derivative at B is 1 over C. Okay? So if F has the point 2, 3, and F prime at this x coordinate is 4, G, the inverse, has the point 3, 2, and G prime at its x coordinate 3 would be 1/4. That's it. And that's all you need to know for this lesson. It's very simple. I'm going to potentially breeze through this lesson uh, in this homework video. See if you can keep up. Okay, G prime of 4, what is it? All right, here's what I do. Ready? Start with our table. The goal is to find this value. Okay, so it's G prime when we have an x coordinate of 4. We then say, okay, I got to focus on this point G at 4. But then we think about F. Now, I'm not going to find F prime of 4. No, watch. I need to find the derivative of F when its y coordinate is 4. Okay. F's y coordinate is 4 here when x is 2. So I'm going to look at F prime of 2, and that will help me find G prime of 4. So it's like x coordinate, that turns into a y coordinate of its inverse. Find the derivative at that y coordinate, derivative at that point, whatever you want to do, or the derivative at the corresponding x coordinate. So F prime of 2 is negative a half. So that means G prime of 4 is negative 2. Okay? So G prime of 3. Ready? Here's what we do. I want to find G prime of 3. I will focus on G and its point where its x coordinate's 3. Well, F, the whole inverse, means the point's flip-flopped. Now, if the point's flip-flop, that means I need to focus on F's point where its y-coordinate is 3. Now look here, I see F's got a y-coordinate 3 when its x-coordinate's 4. So that means to find g prime of 3 at this point 3, 4, we're going to look at F's point 4, 3 and F prime at this x-coordinate 4. Notice these x-coordinates are different. This is very important. Past homework videos, I did not stress this, so I'm redoing the homework video. F prime of 4 is negative 4. G prime of 3 is negative 1/4. Okay. Just reciprocals, dy over dx turns into a dx over dy. Flip it, it's a dy over dx again. All right, g prime of 2, again, what do? Start with, okay, I got to find g prime of 2. And maybe you do it in different order where like you do g first on the top and then you do f, but I like to do it this way. I don't know why. So I'm focusing on g that has an x-coordinate of 2. Well, inverses have flip-flop points, so that I'm looking for f when its y-coordinate is 2 and its derivative at whatever that x-coordinate is. Not at 2. I'm not going to look at 2. I'm going to say, okay, f's got a y-coordinate that's 2 when x is 3. So we have the point 3, 2. F prime of 3. F prime of 3 is 5. Whoop. F prime of 3 is 5. So at the point 2, 3, g prime of 2 is 1/5. Okay, this is a table. This is inverses. The way we kind of saw this using the inverse functions we were talking about, e to the x, log x. Like, let's look at f of 2. F of 2 is e squared. So 2e squared is on the graph of e to the x. Now let's look at g of e squared. Well, the log of e squared was 2. So g's got the point e squared 2. The derivative of e to the x is e to the x. So the derivative of e to the x at 2 is e squared. The derivative of log x is 1 over x. So the derivative of log x at e squared is 1 over e squared. See how they're reciprocals of each other? There it goes. That's this table. This table. All right, same deal. Now it's f inverse prime. Okay, so f inverse can be thought of as g. If you want to flip it, fine, but let's just do it with f inverse. F inverse prime at 5. What is it? Well, I need the point f inverse when its x-coordinate is 5. I'm going to look at the point of f where it has a y-coordinate of 5 and the derivative at that corresponding x-coordinate. So f's y-coordinate is 5 at 4. So I need to find f prime of 4 at 0. Well, that means this is 1 over 0, which is undefined. Okay, cool. F inverse prime of 4. What's that? Well, f inverse, not prime, but f inverse. We're going to focus on the point where its x-coordinate is 4. F has flip-flop points. That's what it means to be inverses. They'll undo each other. Y-coordinate's 4. F of 3 is 4. If I find the derivative at this x-coordinate 3, I get 2/5. The derivative of the inverse function at 4 would be 5/2. Let's move up here. F inverse prime of 3, what is that? F inverse 0.3 something. F's got the point something 3. The corresponding point, the flip-flop slopes, flip-flop points, flip-flop slopes. F prime of, what's that x-coordinate? Let's find it. F of 2 is 3. F prime of 2 is 1/6. This slope has got to be 6, the reciprocal. 2, 3 slopes 1/6. 3, 2 slopes 6. You can double check this with like x squared and root x. Last one, f inverse prime of 2. F inverse prime of 2. Focus on f inverse point at 2 comma something. So f We're going to focus on the point where its y coordinates 2. F's y coordinates 2 is at 1. F prime of 1 is 5. F inverse prime of 2 has to be 1/5. Okay, 1/5 is the answer. 5/2 is the answer. Undefined is the answer. All right, given f of g of x equals x, this is showing you that f and g have inverses. Find the derivative of the point given and some information. So they're hooking you up here. They're asking you what's g prime of 3, and then they give you a random point on f. They give you this random point to help you. Uh, Let me show you what I mean by that. You're trying to find g prime of 3, right? All right, so g's got the point 3 something. Well, that means I need to find when this function equals 3. When is its y coordinate 3? Now, if you try to solve that by hand, that'd be tough. It's x squared plus x squared, x cubed plus x squared plus x equals 3. Even if you move the 3 over, you'd have to do some crazy factoring. But like they're telling you, hey guys, look, f of 1 is 3. That's just it. F of 1 is 3. Which means I need to find f prime of 1. If I do so, I'll know what g prime of 3 is. I'll just take the reciprocal of it. Well, one extra step with these problems is actually having to take a derivative. Plug in 1. I'm not plugging in 3. G prime of 3 corresponds with f prime of 1. G's got the point 3, 1, f's got the point 1, 3. G prime of 3 will be the reciprocal of f prime of 1. So this is where everybody makes mistakes. They plug in 3 because they're like, oh, it's 3. It's like, well, you got to be careful, okay? So this is 3 plus 2 plus 1, which is 6. So g prime of 3 is 1/6. G prime of 1. What is that? Well, I don't even know that. That's 0. I mean, not yet, but okay. Focus on f. When its y coordinates 1. When its y coordinates 1. When this y coordinates 1. Whoa, wait. I'm told f of 0 is 1. They usually give these points on the AB exam, not necessarily the BC exam. Okay. To find g prime of 1, I need f prime of 0. So I need to find the derivative. E to the negative x is an O and an I. The derivative of e to the power is e to the power. Derivative of negative x is -1. So that's negative e to the negative x because I'm multiplying these together. That's the derivative. Plug in 0. F prime of 0 will correspond with g prime of 1. 2 plus negative e to the 0. That's 2 plus -1. That's just 1. So the slips are the same because the flip of 1 is 1. Cool. Good. What's g prime of 1? Well, I don't have g, but I do have f. I don't know why I keep putting words. Well, so that means I need to focus my attention on when f has a y coordinate of 1, and if we find the derivative of f at that x coordinate. Told f of 2 is 1. That's because this equals 1 when x is 2. That's why. It's like that point has to work on the function. So 2 is what I found. F of 2 is 1. That means if I find f prime of 2, flip it, I get g prime of 1. This is an O and an I. Good little practice for our derivatives. Can multiply things together to get 6. What starts in the parentheses stays in the parentheses. Plugging in 1. 6 times 2 minus 3 squared. That's 6. So that's negative. Not negative. That's 1/6. Fun. Good derivative rules practice with these. G prime of 4. I don't know. G, x coordinate 4. I don't know. Okay, focus my attention on f when its y coordinate's 4. Oh, at 2, because if I plug in 2, I get 4 over 1, which is 4. You could solve that equation if you wanted to. 2x over x minus 1 equals 4. So I need to find f prime of 2, and then I'll know g prime of 4, these x coordinates. Quotient rule. Derivative to the top. This is f prime. Derivative of the top times the bottom, minus the derivative of the bottom times the top. Derivative of the bottom is just 1 times the top. 1 times 2x, all over the bottom squared. Maybe simplify. 2x minus 2 minus 2x over x minus 1 squared. Gives me negative 2 over x minus 1 squared. F prime of 2 is negative 2. Plug in 2. 2 minus 1, 1 squared. Negative 2. It means g prime 4, negative a half. There you go. Oh, great. Thanks, Mr. Mister. G prime of negative 4 is something. G, negative 4 comma something. F. Oh, they're telling me on the y coordinates negative 4, the x coordinates. Sometimes they give you multiple points. Okay, maybe I'll give that to you on another question. You're not going to use all of them. Okay, you got to pick the right point to use. If I gave you what f of negative 4 is, a lot of people, maybe it's going to be a big number, but a lot of people will use that number. It's like, no. It's not when f has an x coordinate of negative 4. It's when f has a y coordinate of negative 4. So be careful. You have multiple points, like in the tables, you got to use the right point. All right, so I need to find f prime of 2. Great. All right, well, we have a product rule, and within the product rule, there's a chain. Derivative of the first times the second, plus the derivative of the second. Oh, and I this if you're unsure, but i's derivative is just 1, so the derivative of O is 3 x minus 3 squared. The derivative of the second is that times the first. Fortunately, I don't have to factor this. I just have to plug in 2. 4 times negative 1 cubed plus 3 times negative 1 squared times 4. Negative 4 plus 12 is 8. 1/8 is my answer. G prime of 1, I don't know. Point on G when x coordinates 1, I don't know. Actually, I do know. It's going to be 1, 0, because f's got the point 0, 1. F prime of 0 is what I want to find, and then I'll find G prime of 1. This is an O and an I, e to the power x squared, 2x, e to the power. So f prime is e to the x squared times 2x. If I plugged in 0, plugging in 0 into this, e to 0 times 0 is 0. That means g prime of 1, 1 over 0, which is undefined. Okay. Write an equation of the tangent to g at x equals 3. You'll need to discover g of 3 in both cases. Okay, cool. So I'm not giving you extra points. You're gonna find it. It's not gonna be bad though. Ready? So equation of the tangent to g. Now, we could have done this for all the previous problems. After you have your point and your slope on g, you just use those two. Your point, well, that's not going to be a good example. After you have your point and your slope on g, y minus y1 equals x1, slope x minus x1. So this has nothing to do with f6, 2, 1. I'm using the point 1, 2, and 1, 6. If you have the table, it shouldn't be a problem. So that's what I'm going to do here. I need the point and the slope of g at 3. So I need g prime of the x coordinate 3. I need g's point 3 something. Okay, well, that means I need to figure out when this equals 3, right? Because f, we're talking about the corresponding point when its y coordinate's 3. I can actually solve this pretty easily and get x equals 2. It's not plus or minus 2. Negative 2 cubed is negative 8. So 2, 3, 3, 2. F prime of 2. F prime is 3x squared minus 0. The derivative of 5 is 0. F prime of 2 is 12. G prime of 3 is 1/12. What's the equation of your tangent? Y minus y1 equals that m, x minus x1. Use the point on G, use the slope on G. Some people have things flip-flop, but don't. Okay, this one, it's not going to be easy to solve, but we'll be able to figure it out. G prime of 3, what's that? Well, G 3 comma something. Let's focus our attention on F because that's what's given to me. Y coordinate's 3. When will this y coordinate be 3? It's like, oh, maybe subtract. No, it's just like, look, 1 plus 1 plus 1 is 3. This is one of those where like sometimes it's easier to just figure it out. Plug in 1, you get 3. 1, 3. So that means I need to find f prime of 1. Let's find f prime of x first. 3x squared plus 2x. F prime of 1, 5. So G's got the point 3, 1. G prime of 3 is 1/5. Y minus 1 equals 1/5 x minus 3. All right, now we're into inverse trig functions. There's multiple ways to kind of deal with these. I'm not going to show you how we get the derivatives until next unit because it involves a different type of derivative technique that you don't know about. For right now, you kind of just have to know it, and really in the future, you just have to remember it. It's one of the few things you have to memorize are all these derivative rules. This one included. Derivative of arctangent, 1 over 1 plus x squared. Derivative of arc sine, 1 over root 1 minus x squared. The derivative of arc cosine, negative 1 over root 1 minus x squared. Okay? I'll show you that in the future. If this was just parentheses, this would be parentheses, this would be parentheses, this would be parentheses, right? So if you have a chain, it's an O and an I. O is arc sine, parentheses, I is 3x. O's derivative is 1 over root 1 minus parentheses squared. That entire 3x needs to go in there. So f prime, 1 over root 1 minus 3x squared times 3. Now, if you needed to simplify, I could put the 3 up top, and I'd square the bottom. When you square the bottom, make sure you square 3 and x. 3x times 3x is 9x squared. Usually when I plug things in, I don't square because it's just like an extra step of simplification. And if I had to find f prime of, say, 1/3, I would just plug in 1/3. It'd be easy. So this is another O and I. O is the tan inverse, arctangent. I is x squared. If I had parentheses, it's 1 over 1 plus parentheses squared. Derivative of x squared, 2x. Okay, what starts in the parentheses stays in the parentheses. If I were to simplify this, I'd write this as 2x over 1 plus x squared squared is x to the 4th. People are having difficulties plugging in values or knowing what to do, like 3 squared cubed. They're like, yeah, that's x to the 6th. But then if you had like 2 cubed, people are writing 6. No, it's 2 times 2 times 2. Just be careful, I guess. 2 squared cubed. It's 4 cubed. I don't know. Let's just make sure we understand that stuff. Take your time. That was a mistake made on a quiz. All right, now there's multiple ways to do these last four problems, and I could use the table method, but it confuses a lot of students. So I'm going to go straight derivative rule. Okay, if you know the derivative rule, you can answer this question fairly easily. Okay, find f prime. Now I could say, oh, f is going to be the inverse of like sine 2x over 2, but like, I don't want you to get into that. Let's just keep it simple. Let's take the derivative using our derivative rules. Sine inverse is the outside, 2x is the inside. Derivative 2x is 2. The derivative of sine inverse parentheses is 1 over root 1 minus parentheses squared. Okay, so here's f prime. 1 over root 1 minus what's in the parentheses? 2x, that's being squared, times 2. I'm not going to simplify. I'm going to plug in root 3 over 4. Maybe I'll put the 2 up top. 2 over root 1 minus 2 times root 3 over 4 squared. Don't square it until you simplify this. Like that's something you got to do. Turns into root 3 over 2. Now root 3 over 2 squared, root 3 over 2 times root 3 over 2 is 3 over 4. Now, watch what happens here. 2 over root, and you got to be able to do this. 4 fourths minus 3 fourths is 1 fourth. Square root of 1 fourth, square root of the top and the square root of the bottom, just turns into 1 half. 1 half times 1 half is 1 fourth. 2 divided by a half is the same as 2 divided by 2 times 2. The answer to the question is 4. I can show you how to get that answer a different way, but I don't want to confuse you. This is the way to do it, just knowing the derivative rules. Okay, so let's do the last three. It's the same thing. Let's find the derivative. Tan inverse, parentheses, multiplied by 4, 1 over 1 plus parentheses squared. So f prime is 1 over 1 plus parentheses squared times 4. This is 4 over 1 plus 4x squared. I'm trying to find f prime of 1 fourth. I'm not simplifying this yet. I have 4 over 1 plus 4 times 1 fourth, which is just 1. 1 squared is just 1. I have 4 divided by 2. That's 2. That's my answer. I can show you a different way to get that, but I don't want to confuse you. This is the simplest one. All right. Well, our coast, this is easy. There's no chain. It's just negative 1 over root 1 minus parentheses squared, or just x squared. And plug in root 2 over 2. Notice how I'm plugging it in parentheses. Like, this is important. Whenever you're substituting, use parentheses when you substitute. It's good technique. Order of operations. Square root 2 over 2. So root 2 over 2 times root 2 over 2 is 2 over 4, which is just 1 half. So that's 1 half. Square root of 1 half, I'm going to write as 1 over root 2. Square root at the top, square root at the bottom. Square root of 1 is 1. Keep James change. Negative 1 times root 2 over 1 is negative root 2. Yep. All right, last one. O and I. Right at the correct derivative. It's the easiest way to do these inverse trig problems. 1 over root 1 minus parentheses squared times 4. Plugging in 1/8. 1 over root 1 minus what starts in the parentheses stays in the parentheses, 4x squared times 4. Move the 4 to the top, plug in 1/8. 4 over root 1 minus 4 over 8 is 1/2. Square 1/2, we get 1/4. 4/4 minus 1/4 is 3/4. Square root of 3 over the square root of 4. That's the same as root 3 over 2. Keep flip, so that's 4 times 2 over root 3. So that's 8 over root 3, which if you want to rationalize is 8 root 3 over 3. Multiply the top and bottom by root 3 over 3. It's the correct answer. I could show you how to get that using sine of 4x, no, sine of x over 4, and its derivative at the point when its y coordinate is 1/8, which will be like pi over 6. Yeah, I don't want to do that. It's confusing. So that's it. Those are your inverse derivatives. I mean, I don't think it's a tough lesson. 2 things to know, your table, as well as your inverse trig derivatives. So hopefully we're good with this. Hopefully this video makes sense. Peace.